Bruce Betts is the Planetary Society's chief scientist and the LightSail program manager. He is also the author of many wonderful books for young people about space and science. He is, I guess, beginning work on a very exciting new book that'll be a big part of our conversation today. More about that later, just a tease for now. Bruce, what's the current book count? Do you know?
Published is 6 and 9 in the pipeline.
That's not
just
that's
9
impressive.
in the pipeline.
That's right. That's why I call him the Stephen King of the Planetary Society. And there's one of the ones that's coming up, right, is going to be of great interest to our members and a lot of other people around the world, or at least in the path of totality. You've got an eclipse book coming, don't you?
Yeah.
We sure do. The Planetary Society presents Casting Shadows by me, an eclipse book for kids, but really for anyone. Solar and lunar eclipses discussion from Learner Books will be out in January.
Good timing, since we are all looking forward to that total solar eclipse in April. Stay tuned, everybody. I'm sorry. Was it supposed to be a surprise? Well. Planetary.org/eclipse if you want to look up that other project, but there will be much, much more for us to announce in the coming weeks. Jennifer Vaughn is the Chief Operating Officer of the Planetary Society. You have been with the Society, I think it's for over 25 years, Jennifer?
That is true. That is very true, yes.
And
it went by like that. It was just a moment, a blip in my life.
I know exactly what you mean. I know exactly what you mean. With the possible exception of Bruce and I guess Bill Nye, I don't know of anybody whose passion for this project equals yours. You want to give us some of your thoughts and just introduce us to this topic as we look back and then look forward to the next chapter in the LightSail saga.
Yeah, absolutely. So indeed, enthusiasm is a good word for it. I'm also just immensely grateful all the time. I just feel such gratitude for what we collectively have been able to achieve. It still stuns me. So LightSail is by far the largest, most ambitious, most complex, most expensive thing that the Society has ever done. And those of you who have heard me talk about it before know it wasn't an easy road. This was 20 years in the making. Spacecraft failure or launch vehicle failures that caused our spacecraft to go in the ocean, having to restart, rethink, and then coming to a point and recognizing there was still so much work to do because we were doing something that hadn't been done before. And whenever that happens, there are unexpected issues that come up. And there was a point where we really felt like, oh man, are we going to be able to do this? Can we still pull this off? And we know now the answer to that question was, yes, we pulled it off and it worked and it was amazing. And there's so much that we can be proud of. And part of that now is sharing that story, not that story, those stories, these stories. There are so many of them to tell within the story of LightSail. And it is, depending on what you're most interested in, I think that you're going to find things about the stories of LightSail that will inspire you, that will make you think what's possible, think more large about the possibilities of individuals being able to influence the future of space exploration. It's very exciting for me. So I feel like we are just, everywhere you look around this office, I'm at the office right now, there's LightSail memorabilia, there's pieces of history, there's original writings, there's patches and all kinds of neat artwork all around, and I've got some samples to show later. And part of that is we want to make sure that there is a place to share that with all of you. Additionally, I want to say that, and we'll talk about this a little bit more, we have this long-term partnership with an institution here in Pasadena, the Huntington Library, that takes all the archives of the Planetary Society. And this is for long-term, so probably centuries of archives, right? So this is for a very long-term archiving, and it's all available to people if you jump through some hoops to be able to go see those items. Part of what we want to do is before we hand them over to the Huntington, that we share them in more accessible forms, both with the professional community and with all of you and anyone who might become interested in this topic in the future. So that's really the spirit behind the LightSail Legacy project approach that we're doing. So the next couple of years for us is going to be about doing just that: archiving, sharing, and working with the professional community to advance solar sailing.
I can't wait to see some of those objet d'art that you apparently have to show us. But I also want to mention, any of you who come to Pasadena, first of all, welcome to our hometown. But second, don't miss the Huntington Library and Gardens. You may not get into the Planetary Society archives, but it is truly one of the wonders of the world, visiting that place. And it is such, I am so proud of the fact that our archives are part of the grand collection there at the Huntington. It really is a pretty impressive thing. Bruce, you have got to be, I know you are always itching to share images from LightSail. I knew it. But I'm hoping that maybe first you can take us through a little bit of what we've learned and what we have shared with others, with the international space exploration community, thanks to this project. Just an overview. Oh, you're muted.
It's better that way, you know that. What? That's a really cool object. Who are those two handsome guys?
There are only two of these in existence, and the other one is not in the Huntington.
It's in a hermetically sealed jar on Funk and Wagnall's porch since noon today. Obscure Tonight Show references from the Johnny Carson Show. All right, let's go on. Let me see if I can. Well, first, let me just say how excited I am about this. We have flown a mission. It was often stressful, often exciting. We got lots of pretty pictures, which makes me happy, but we did real science, technical, and valuable work in promoting solar sailing and raising its view to the world. And I've been involved off and on with it since the beginning of LightSail, pretty much in 2008, 2009. And so let's take a look at some of them pretty pictures, but also give you a little of the overview you wanted. Let me see if I can successfully share my screen since I did so well with the mute button. Let's see. How about this one?
We wait in suspense. Hey, there you go. You are up and running. Looks pretty.
All right. LightSail Legacy. So it is not darkness, but in the beginning there was darkness. And then I wanted to share my personal two pictures that capture kind of my legacy history with the activity. In 2009, we were talking about this and designing the designs for a LightSail spacecraft and trying to figure out where you could put a camera. And they were like, the only place we can put it is maybe on these wings. It'll be really low down. I got tired of trying to do it in a theoretical or computer simulation sense. So 2 buildings ago, the Planetary Society had a big concrete patio. So I marked it off in the size of a LightSail prototype, what the screen would be, took pictures at various height levels, used these advanced soda cans, which we ended up not flying, surprisingly enough, on LightSail, either of the LightSail missions, to see what it would look like. And you skip ahead just a mere 13 years later to the last image returned by the LightSail 2 spacecraft, and it looks almost the same.
Sans Diet Coke cans.
I pushed for those, but the sponsorship deal didn't come through.
Yeah.
Just kidding. This is, by the way, while we're at it, South America. It's kind of central part of South America, Bolivia, the Uyuni, and I'm sorry if I didn't pronounce that right, salt flats. These amazing, huge salt flats are the white big thing in the middle of the screen, and then Pacific Ocean off to the east, off the Andes we're over, and then LightSail in its most abused format, the sail after some degradation from hanging out in space for 3.5 years. But let me go over. We did it! Hey. That's important to remember. We took on an amazing challenge. I mean all of the membership, all the people who contributed to this, all the many tens, potentially hundreds of people who worked on LightSail related activities over the years, going all the way back to previous Cosmos One efforts with solar sailing, but we did it. And the LightSail program is, first and foremost, funded solely by 50,000 members and supporters. In other words, thank you. Good night. No, not good night. Thank you for all who supported this. This was done entirely through individual donations. It's an amazing success, and Jennifer can talk much more about this. She is published in a book talking about the amazing crowdfunding and such. So I will not go on about that. I will talk about LightSail program. And so here we have 2 sequences of 5 images showing the LightSail sail deployment. We had 2 cameras looking opposite directions, fisheye lenses, and this is over about a 2 to 3 minute period. The LightSail sail was pulled out, and this is what we captured, with Baja California being the strip of land down in the images at the bottom. What were our program goals? Well, demonstrate controlled CubeSat solar sail propulsion. This, this goes back. We've been working with solar sailing for a long time. Lou Friedman, emeritus director, was worked on this at JPL with really big things that never happened in terms of solar sails. Brought the idea here, supported by Carl Sagan, Bruce Murray, the founders, and in 2005, Planetary Society tried to fly Cosmos One, a very big sail that had a launch failure, working with the Russians. And then in 2010, the Japanese successfully flew Icaros, being the first solar sail mission. But in that time, we developed a little tiny spacecraft called CubeSats, not we, but the technical community, that could piggyback rides, but lacked volume and space. So we wondered, is this the niche we could fill to demonstrate that you can actually use this as a propulsion method where you don't have to take fuel? And indeed, we did that. We also wanted to raise the public and technical profile of solar sailing. And that is actually one of our biggest successes, I think, based upon what's been told to us by the heads of proposed missions, accepted missions from NASA, saying, you can't beat having that demonstration and the pictures that you demonstrated that you could do this, to have it accepted as a more viable technique. It's much better than any just write-ups and papers over and over again. So that succeeded, but we still have more to do in that, and we have more to convey and excite and engage the public. Well, I hope those of you who are here excited, and we engaged you in the process. And that's something that will be ongoing. And then this is the real part, that the legacy, not the real part, this is one. Basically, we did number 1. We've published the papers in peer-reviewed journals. We've presented at conferences. But we're working still on 2, 3, and 4 to do them better. And we want to, through this legacy program, through this legacy mission, share the results of what we learned, all the images, all the telemetry data, publish scientific papers, present at conferences, have articles on the web, and get the information out there, have an archive where this will have value into the future. We did a lot of work from a lot of people and a lot of support, and so being able to share it is, and making sure we get that jump done properly, is what we're trying to do. A very wise person once said, "The spacecraft is gone, but our mission is not over." LightSail Legacy Mission, what I'm calling it, because it really is an extension of the mission. Our mission is not over. Ensure the legacy and impact. So that's those, getting the information out, getting things archived, making sure that all the work we did is out there for people to use in future solar sail missions and future activities, and continue to get people excited. So we're doing that through continued collaboration with the solar sailing community missions. We worked with NASA on NEA Scout, which unfortunately had a communications failure at the beginning. It was going to go off to an asteroid with a solar sail mission, launched, failed. We worked with Solar Cruiser with NASA, which is in kind of a limbo and going out farther if it ever revives, but it's doing a lot of technology work. And then ACS-3, which is a NASA mission that'll do Earth orbiting. We've collaborated with them, but we also attend, and I'm on the technical committee for the International Symposium for Space Sailing, which happens every couple of years and brings together the sailing communities, space sailing. And then, of course, we're doing, well, maybe not of course, we continue to do journal publications and technical presentations at conferences as we take all the data that basically we had a very small team. This is a very shoestring project to do. And so we had a small operations team. It was not, it's hard to do much more than successfully fly and choose the right data. So we're still writing up the results and analyzing the results. And then create publicly accessible archives. So this is the archive I'm talking about, where you have the engineering, the imaging data, support materials that can be accessed by anyone going into the future. But there are preparations and efforts that need to be done to prepare the data to be in a friendly format. And finally, and maybe Jennifer also wants to talk more about this as well, produce the LightSail coffee table book. Basically, we've got a lot of really pretty images. We've got amazing stories over 13 years of this program. So LightSail book is a way to try to tell the story through pictures, and also with text write-ups to complement it and make sure that this moment in history isn't forgotten, that the members have a tangible thing that they can show to people, but also that there's a record. There's a lack of solar sailing books out there, particularly friendly ones that don't have lots of ugly equations, which you end up not using most of them anyway. So that's kind of the gist. We've published recently, by the way, Justin Mansell is a great story. He was on our team. He started as a grad student at Purdue with Dave Spencer, our project manager. Graduated. He now works at JPL, doing JPL aerospace engineering stuff. He's got with his PhD from Purdue, and part of his PhD was working with us. And he's published the key paper taking and looking at solar sail control and how the orbit changed and what we learned from that. And that's an aerospace peer-reviewed journal. This is a recent, basically presentation in a conference paper led by Dave Spencer at SmallSat conference this summer. This is a presentation that I did, folks. Dave was doing the overview of the mission, and then I've been talking about image-based engineering assessment. So not just the pretty picture part, but using it to study the spacecraft, and that will result in a peer-reviewed publication down the road. And if you want to learn more, if you want to find those publications, you can go to sail.planetary.org. There is a link halfway down the page or so to technical articles. You can find all sorts of technical articles if you want them. Planetary.org/mission control. You can go and stare at it and hope that it changes and that we're still up. It won't happen. We burned up in November as expected, but that's there and has a lot of links to prior stories. And finally, planetary.org/legacy is where you can contribute to this final piece, this extended mission of the Planetary Society. Finally, and I'm sorry, Matt, I always take too long, but I have to get to my images, and I babbled so much. So Nicole, who helped put this all together and is one of the wizards of the Planetary Society, said she hadn't actually seen some of the unprocessed image and the processes that went into processing. And so I thought I'd share. This is how that picture we saw of South America, this is what comes down first. And so we had, thumbnails. So we had very low data rate. And so we sent down 120 pixels by 90 pixels, which I've blown up to the screen. And then I would stare at them and try to not turn it into a Rorschach test and figure out which ones were worth taking data to downlink the high-res version. And then, here you can flip it and you can start to recognize things a little bit. And then here's the high-res version. And then we do some geometric correction because it's a fisheye lens, make the colors look prettier, and you end up with what we put on our website and what goes out there. Let me show you two more examples. You can try to figure out where are we in the world. And this is the low res, obviously. This is unprocessed and processed. And this is all of middle Australia with north kind of over at the left. And the southern, you can go from the north shore to the south shore of Australia. There are shadows of the solar panels that stick up from the spacecraft on top, which helped us figure out we had one floppy panel that didn't fully deploy, which you can see in the upper upper left, the shadow of that. And finally, here is, so you stare at this image, go ahead, I challenge you to figure out where we are in the world from this image. Now, I knew where we were when we took the picture, but I still couldn't figure out anything. So I kind of rolled the dice on this one. And we brought it down, and it turned into this. It turned into this, and then I thought, let's flip it over. And you've got beautiful shadows on the sail. And this is French Guiana, Suriname, and it's the northeastern corner of South America. North is roughly at the top. The Amazon Delta is just under the sail there, and it turned out to be one of the pictures people likes the best that we shot. So there's a little insight, for better or for worse, into the process, and now just pretty pictures. Red Sea, Arabia, this was the second to last picture taken by LightSail 2.
Gorgeous.
And this is Indonesia with reflection, sun reflection off the sea there. Sumatra is just, north is roughly at the top. Sumatra, you can see just underneath the central tip of the sail.
And there's a good bend in the boom on that one too.
Yeah, so we also had one of our 4 metal booms that came out actually had a bend in it, and it's the imaging that told us that. And so we didn't extend anything anymore. We're careful with it, got some idea what's going on with it. You can also see some of the degradation in the sail, which is mostly from atomic oxygen, and that's like this orange in the center of the sail. And here is a tropical storm, Minine, always good with pronunciation. I was spot on, I'm sure. And this is off Japan 8/7/21, which for those playing the sports game was when the Olympics were held in Japan. And this was a storm that was headed towards the Olympics, didn't really hit much of Japan. And that one you might recognize is Florida and the beautiful waters of the Bahamas, which are stunning and stand out. And if you look, there's a little speck over in the left center. That is the moon. Moon looks very tiny because, again, we have a fisheye lens. And this is this is 2 pictures in a row to give you an idea of our movement. So this is Egypt. The north is at the right. This snaky thing is the Nile River. So maybe pay attention to the just right of center of the sail. The dark areas, the lakes and the Nile there. And then 2 minutes later, we've moved, and that's back here, and we're over the Red Sea, and you can see the Mediterranean there. And I love a Madagascar picture. I worked really hard to get Madagascar, and there it is. And there's Mozambique down to the lower left, and the Mozambique Channel. And finally, moonlight becomes light sail. That's the moon. Sorry, I apologize.
You should.
The moon over the sail when we're in the shadow of the earth, full moon. All right, I turn it back over to you, Matt, and I apologize for babbling on. I get so excited sometimes.
I know. It's all right. We all understand. It is gorgeous, gorgeous work. And your role, I mean, in addition to managing the entire program, you were basically selecting these photos, right? I mean, you were deciding where to point LightSail to grab the photos, and then you were doing all the processing.
Most of it. There were others helping out, but yeah, because we had a small team, we literally had 5 of us that ran spacecraft operations once we got into the flow of things, all of whom had other jobs. We would meet daily, figure things out, and I would stare at our orbit and what was coming up and try to match it to the right times to make the batteries happy, figure out when there were going to be clouds over someplace or not 2 days later, and then roll the dice on what I actually got from the 2 cameras. And it worked out. So yeah, it was a unexpected fun thing in my planetary career to play with images. And of course, we're not getting NASA NOAA level Earth remote sensing images that are teaching us about the Earth, but we're getting super cool images that are inspiring and exciting people. And I think having that shiny sail down below just adds to it. But then I am thoroughly biased on that point.
I have never seen a NASA or NOAA image of our planet with light sail wings visible in the image. So I think we've got something up on them. Looking at some of the degradation of the sail, like you just pointed out, makes me think of that other data, not just the images that you've been referring to, that we want to share and that you've been presenting about. Is this what I've heard a reference to, what is called the master archive, which I assume is where all of this stuff is put? Where is that now? Where does that live?
I can't tell you.
It's not behind my refrigerator, is it?
I can't. I can neither confirm nor deny. Right now, it's spread on various computer systems in formats that those of us with the mission can play with easily. And I don't know about easily, but we can play with. And so our goal is to make it in a friendlier format. And I'll be consulting with our technical staff, computer staff, and we'll figure out the best way to host it, whether it's a website or so there'll be some website entrance, but exactly where it's hosted and how we make it easiest for people is yet to be determined. So we have the pieces, we need to make them a little friendlier. You can actually access a fair amount of the telemetry data, the engineering data, online right now at the mission control site. There's a link that'll download a lot of it. You can also access orbital data, the orbital descriptions from the tracking people and such things. Sorry, I got distracted by the chat. Justin Foley, hey Justin Foley.
Justin Foley, another one of those members of the team. Yeah, I was going to bring up the students you mentioned. Now we've mentioned a couple. The young people who are part of this project, who are going on or have gone on to become space exploration, space science professionals. I mean, this is also something that you must be very proud of as well, Jennifer.
Absolutely. And there was a question actually about working with students, and they were essential to our success. So Bruce already mentioned a little bit about another Justin. We have more than one Justin, and his story about actually going through and making LightSail part of his thesis. But there was more, right, Bruce? I mean, you worked with students throughout the mission.
Yeah, and there were students at Purdue, and at Georgia Tech, but then there were a lot of students we worked with at Cal Poly San Luis Obispo, and that's where we worked with Justin in his previous life, and then he went off to some place with initials that does some kind of space something, JPL, is that right? Yeah, I think so. They
work on jet propulsion there.
Yes. Anyway, Justin Foley was a key member of the team, and he went to Cal Poly, but we worked with him not as a student, but there were a number of students who ran operations, especially early in the mission. So before things were automated, and when we had to keep close tabs on the spacecraft, students are a great way to watch it during terrible passes in the middle of the night, and also just in general to get involved. And so we had a number of very helpful, talented students at Cal Poly San Luis Obispo. So we had students throughout the project. There was an intern who worked with me as part of another program at the Planetary Society. So students were a key component of the activity.
So we are halfway through our nominal hour with all of you, and I know that some of you joined us a little bit later. You probably know that we are talking with Bruce Betts, Chief Scientist of the Planetary Society and LightSail Program Manager, and Jennifer Vaughn, our Chief Operating Officer, COO of the Planetary Society. I don't know if I ever said, but I'm Mat Kaplan, now Senior Communications Advisor for the Society.
Ooh.
So we are getting questions, and you can continue to add yours in the chat area. Those are then being forwarded to me by a prized member of our development team, Robin Young, and I will be getting to one of those in just a second here. Actually, why not do it right now, because it leads into what I want to ask you about next. Mason Howell, hey Mason, says, can you give us an approximate time when the LightSail book will be released? It's really early in the process, right, Jennifer?
Yeah, of course. This is what we're trying to get people excited about this concept and ideally be able to move forward with this project. So everything that's going to go on with this book is going to be in-house. And so for that reason, I'm going to say no earlier than 12 to 18 months. So it's going to be a while. Bruce said it all when he was talking about the master archive. We have all the bits. Same thing for the book. We have all the bits, but pulling that into a cohesive story and then going through the production process of a book just inherently takes time. There's no way around it. Bruce knows that with the books that he said he has 9 in the pipeline. They don't come out. 8 of those don't come out until next, I don't know, August of 24 or something. So it just takes a while to do this. But we're ready. We've been working what would go into this book. We are ready to start moving on it. So I think as soon as we get the go, we will be off and running, and we'll be giving you updates all along about where we are with things and what to expect as well.
Won't be cheap to create the kind of book that I think that you have in mind, right? Because lots of pictures, and we want to tell the whole story, right?
Yeah, I mean, that's the thing is that we really feel like the star of this book is the images. So that's why we decided that the kind of a coffee table style of book was the right approach for this. So the images are very much the star of the experience of the book. But along that, then of course, then there's also the writing and the editing and the work that takes place there as well. So for all those reasons, indeed, it's not necessarily the cheapest way to go about things, but we really want this to have some impact in people's lives and some long-lasting value to the world. So someone, I can't remember if it was you, I think it was Bruce actually, who mentioned how few books exist on solar sailing at all. This is a very small group of others that we would be joining. And so anyone, I think, who has an interest in solar sailing would quickly find this opportunity to get more involved in what we did, learn about LightSail, learn about the community of people that made LightSail happen. So I think it's a great niche for us, and also just for the organization itself. This is, as I said, the highest profile thing we've ever done. So it's worthwhile to me to really invest in developing that cohesive story now, while all the memories are fresh, while all the people are still here. That's the best time to do archival work, is do it in the moment, not looking back 20 years. So I'm really inspired to do this right now and do it well, and make sure that we have a piece that will live for a couple generations here.
I cannot wait to get it on a coffee table here in my home. I really am looking forward to this. And I hope that I'm sure it will contain a lot of the human stories around this project. I thought back when you were showing the images of deployment, Bruce, I was thinking back to where we were, the 3 of us and many other people at Cal Poly, the 2 of you, I think, sitting next to each other. And I was across the hall with a bunch of other people with Bill Nye live on a TV screen, because he couldn't be there for deployment. But he wanted to be. And the elation that went through the room when we started to hear those numbers, because we knew that the sail was being extended by those booms. It was one of the most exciting moments of my life. And I'm sure you'll try to capture that in the book.
I was just talking about this morning, and Bruce was reminding me too that it really was an extraordinary moment. Because when you see any kind of images from that, everyone is so genuinely, I don't know, just vibrant and optimistic, and there's just so much excitement that you see in people's faces. And those moments are special, and indeed, that's a good example of, it's not, although the images from space are the star, would be the star of the book. There are so many other visuals that we have to share. And we have photographs of the people throughout. We have great graphics that we've developed over time. And I said some of the interesting artwork, and I'll just show a couple things. So I don't have everything to show right now, but we had our own art that took place. So the first thing I want to show is this little LightSail patch. And this is old. This is actually, oh yeah, that's the one you have there. Yeah, so this is before the missions really took shape. So this was kind of a LightSail program patch that was designed by Mat Kaplan. from Star Trek fame. So the designer on Star Trek. So this is a kind of the original look of our LightSail. And then over time, then when we were getting ready to launch, we did launch patches for particular missions. So LightSail 1, LightSail 2, we have extended missions as well. We also have old Cosmos 1. So the first attempt at solar sailing. So we have great graphics like that to share as well. We have these wonderful models, and there's so many. There's one behind Bruce. You can see the paper models of the spacecraft. But then there's also these like beautiful hanging light sail models as well. We also have the lovely Cosmos 1 with its 8 blades. We have things like jewelry. So this is the light sail necklace. There's earrings like this as well that were created. And then I have one more piece here, which is a weaving that someone did of LightSail and presented it to Bruce. I just took it out of your office. Okay. So in addition, there are things I can't show right now, but there's a wonderful Halloween costume by one of our younger members at the time that we have posted up on our board. But if I took it off, I might have torn it. So I didn't want to do that. We have great handwritten notes from Bill during deployment that was capturing his own excitement in it. These are all things that we want to share because it really just shows the excitement that individuals are having about the mission. So it's part of the other images that we're going to be showcasing and telling the stories around.
Like I said, I can't wait. I want to start getting to more of these questions because we do have lots of participation. And I'm going to start, mostly I'll do these in order, but I can't resist going to Justin Foley, part of the team that brought it all together. He says, hey, LightSail fam, just thought of a question. Did we ever get an estimate of approximately where in the world reentry occurred last November?
No.
Easy one.
Bottom line, I mean, we know the tracks, but since it's going around the Earth every 90 to 100 minutes, it's when you don't know it very precisely, it's an awful lot of places. So, no, they're the estimates from the space tracking part of what's now Space Force. But there's nothing precise, and no one said, "Hey, look at that fireball. That says LightSail too." So sorry, Justin, but you can find it. That I throw it down as a challenge, and then if you can find pieces of the spacecraft, well, that would
wouldn't that be something? Yeah,
pretty much impossible.
That would. And data got really spotty at the end of the mission, right, Bruce?
Yes.
Yeah.
No, our own tracking and data got very spotty because as the orbit decays towards the end in the last few days, it's changing so rapidly, and we're using antenna and tracking systems that need some idea where on the sky they're looking when, and so we didn't do very well at the very end. So largely, we know it stopped communicating, and we know that U.S. Air Force, Space Force type people said, "Hey, it doesn't exist anymore." And we have all the predictions that it was plummeting to the atmosphere.
Well, you were tracking its altitude more or less, right?
Yeah.
So
Yes.
We always knew it was coming. This is one from Curtis Poe. He says, and boy, this is very relevant because on Tuesday, I will be talking to the guy who wrote the original technological book, the one with all those equations you were talking about, our co-founder, Dr. Louis Friedman. Oh, no, I haven't. You're right. But he wrote the one about solar sailing that has now been followed up by his new book, which we will be talking about here in the community on Tuesday. It has been our selection over the last month by Lou, and this is one of the things he talks about. For gravitational slingshots, how close can light sails reasonably get to the sun, which is something Lou addresses in some detail in the book. I guess our light sail, not so close.
Did you not hear me tell you about the burning up in the atmosphere part? No.
There was a story about a Greek guy once.
Yeah, no, that was it was kind of bold for the Japanese space agency, named theirs Icaros. It was a cool acronym, though. Not relevant for ours because ours was designed in order to keep it in any kind of reasonable first attempt and reasonable cost envelope. We decided, and getting a launch, that's the real challenge. We ended up doing an Earth orbiting thing, which is actually one of the harder things to do with solar sailing in some ways, but we were tailored the spacecraft to that. It was not designed for interplanetary, whereas interplanetary is how you want to use these. And I frankly never pondered how close we could get a solar sail to the sun. So I can't handle that. But Parker Solar Probe's doing some really amazing close to the sun stuff. So of course they've got a big old heat shield on theirs that would, I don't know. But Lou has thought about it.
He has, and he also talks about some of the work underway to develop new materials that could, stand the kind of heat that Parker Solar Probe is, but be as light, as low mass as a light sail, a solar sail, light sail is probably going to have to be. It's very interesting. I didn't mention the name of the book. It's Alone But Not Lonely, and I do recommend it. We'll be talking to Lou about that Tuesday at 10 a.m. Pacific, right here. Let's go on to another one, and this is from Albert Hagee. My question is, could LightSail work for interplanetary travel? But wait, there's more. Like for returning core samples. Core samples.
LightSail could not, but a LightSail, a solar sail could. So LightSail had some specific things that Earth, including the communication, wasn't designed for long distance. You use the Earth's magnetic field for some of its fine adjustments on the orientation. But certainly solar sails, this is their future, is to go out in interplanetary space. You can not quite lock the sail, but you don't have to keep changing its orientation every 45 minutes for what you're doing, which is what we did to change the orbital energy. And so you could. Now, core samples, you'd have to rendezvous, as the plan is for Mars sample return. You're not going to do going down to the surface with the very light, tenuous material. But you could conceptually do it with a solar sail, just as you could do it with something else.
Lou also talks about using a sail that's sort of parked in a fast orbit to wait for objects that are coming from outside our solar system and try and rendezvous with them. And, he believes that a sail, perhaps with other technologies, would be a good way to achieve this. Here's a related one from Thomas West. At what order of magnitude do current launch capabilities limit light sail size? Next, what kind of research is going into on-orbit manufacturing or in-situ resource utilization for constructing light sails? Let's start with that first one. How big could a light sail get?
It's unclear because the challenge is whether you can actually do it successfully and deploy it. So whatever you're going to do to shove it in a rocket and have a sail that's big enough to do anything, you're going to have it folded up in some manner. And that means you're going to have to deploy in space. And anytime you deploy in space, you're running a huge risk. And anytime you deploy something really big, you're running a really big risk. And so it's less the size of the volume of the rocket. I'd say at this point, we're more limited by an effective boom type system or non-boom. There are spinning options like the Japanese Space Agency used to deploy and control. It's also harder to control when you've got that big, all that stuff going really far out. So I'm sorry I don't have a specific answer, but I will say it's less the size of the rocket, it's more the technologies that need to be developed and tested to do larger and larger sails.
Speaking of control, Dave Ginsburg asks, how is attitude control achieved?
Oh, attitude control.
Control your attitude, please.
To answer, I didn't answer the second question before, which is, to my knowledge, there's no one working on doing definitely not on in situ resource utilization to make solar sails. That's far off in the future. And even on orbit assembly, I'm not aware of that. It's always possible I missed something, but we're too early in the process. I mean, we took the baby steps, and now we're hoping someone crawls, and eventually we'll walk and run. And now back to new question, which I completely forgot because I smart.
It's those
Attitude control.
I'm out
attitude
of control. I'm out of control.
I'm especially thinking of those huge attitude adjustments every 45 minutes as LightSail went round and round.
Yeah, I have those. So in order to be in orbit around the Earth and change the orbital energy to prove that solar sailing worked, we used the technique where every 45 to 50 minutes we changed from edge onto the sun to face onto the sun. So we'd go towards the sun and then away from the sun. So that's the context. So in order to do that, you need to be able to rotate your spacecraft. You need to hold it at a relatively the right orientation. This is attitude control. It was achieved twofold. There was the large adjustment. The slew was done using a momentum wheel, so a really fast spinning wheel in there that you would change the speed, and then the momentum would transfer to the spacecraft. And we only had one axis to do that, and then the general tweaking of the orientation was done using magneto-torquers, which is what I mentioned. That's something that relies on, basically you push in the X, Y, and Z axis in 3 axes. You have electromagnets, so you turn on a certain magnetic field and it pushes against the Earth's magnetic field depending on where you are in orbit and what the orientation of the field is. And through this seemingly miraculous process to me, you can actually adjust the attitude, and it's actually a common technique in Earth orbit, but you have to use other techniques when you're going into deep space. And so having more momentum wheels, and then you get into the whole without going too deep into it, one of the big challenges for us and for deep space sailing is momentum wheel saturation. So you spin it up, and then you either can't spin it any farther or you spin the thing apart. That tends to be bad. That's a bad thing. And so you limit the amount of spin, but then you have to figure out a way to take that extra momentum out. And that's where we would turn off the slew system and use the magneto-torquers to take out the momentum. You can do it using sliding weights, using tip vanes, all sorts of other stuff. I'll just tease that. Okay, go on.
I'm also thinking of Icaros, right? Which used those LCD panels that could turn on and off.
Yeah, they had some super spiffy technologies they tested out. Now, one thing they couldn't do is turn much. They had a real limitation, very big limitation on how much they could. What we were doing every 90 minutes in our crazy sports car, their origami inspired, genuinely origami inspired folding and unfolding and spinning it out with tip weights, wasn't able to do that. But they had these very clever, they had LCD panels that would change from basically dark to very reflective. And they could change those as the spacecraft spun, just to keep it more challenging and introduce some momentum torque to the spacecraft. So they did it. It was amazing technology. It was very patient, slow technology to achieve what they were after. But it was very
great
clever.
success. Yeah, can we congratulate them, of course?
Yeah, they did amazing stuff.
Liam Comerford, sorry, Liam, was the LightSail done in collaboration with AMSAT, the Ham Radio Satellite Organization? And I will just add to that, if I'd had the proper receiving equipment, would I have been able to receive the signal coming from LightSail as it passed overhead?
Yes. And in fact, the famous Justin Foley we keep mentioning brought a portable antenna to the parking lot of the Planetary Society one day, and we listened to its signal as it passed overhead. So yes, you can set up a setup to do that. There are groups that track, and so we would provide the frequency, and we had the data that would come down in the summary engineering data every 7 seconds, roughly. And then every 45 seconds, there'd be a Morse code continuous wave signal that broadcasts the code of the government agreed upon code of the spacecraft. And we didn't work much very directly with AMSAT, but we certainly worked with the amateur satellite tracking community, and we're paying attention to what they were able to pull down or not pull down from the spacecraft. And a lot of our team members are big amateur radio people. So certainly John Bellardo, who headed the software development and the Cal Poly side of things, is well versed in such things, and as well as being a key member of the team.
It was John Bellardo who insisted that I pull LightSail out of its little carrier when I was at Cal Poly San Luis Obispo. I didn't want to because I was thinking of what you would do to me if I were to drop it.
Yes.
Yeah.
Yes, I was horrified.
Yeah, me too. But it was kind of fun.
Did you happen to touch that one panel?
No, that wasn't me. No, I swear.
All right, just curious.
Laura Monahan. Thanks for joining us, Laura. What were the advantages or challenges of working so closely with a university, with undergrads and grad students on projects like these? Obviously, it benefited the students, but it was good for the project too, I assume. Speaking of Cal Poly,
it was very good. It was very good for the project. There's the standard challenge, which is turnover. So, I mean, Justin Mansell, he was with the project for years and working on a PhD, but undergrads at Cal Poly would turn over every few months. And so you'd have new faces and new people, and they'd have new habits and learn the system. The other thing was we had this challenge that affected us, but I don't think it affected many other people. It was this pandemic thing. And sorry, too soon. And so that cleared out the campus. And so we suddenly didn't have students on site. And so like John Bellardo, as professor, had to pick up a lot of the tracking duties, and he was obviously had other things going on. So we didn't have others that we could assign, hey, go test this part on the BenchSat, the simulated spacecraft. So it really demonstrated how much we missed the students. And we got by, but it made for a harder job for the staff during the period where students weren't on campus. And a lot of that is constrained to the campus in terms of the security reasons and things to keep track of the data and keep everything safe.
I hope people will check out some of the videos as well, including LightSail related videos, including the deployment test when Bill Nye and you and others were up at Cal Poly, and there were tons of students up above looking down on this very slow deployment on a giant table. It was really fun. So we provided all that inspiration as well. Jennifer, here's one for you from Philip Shane. And thank you, Philip, for asking the perennial question that we get about the LightSail program. Will there be a Kickstarter for a LightSail 3?
No, but of course it doesn't end there. So what ended up being LightSail is a very complex story with all kinds of moments that may or may never happen again. When you line everything up and you trace the history, it wasn't as though we sat down and created a whole idea and said, we're going to go after this whole idea immediately. It evolved. It evolved over some adversity and also some opportunity that came our way. So along that line, we are always keeping our eyes open for good ideas, for all levels of good ideas that the organization collectively, that we can come in and we can support. So these might be small advances in technology, these might be particular studies. It also could be something as large and as complex as LightSail. It could even be solar sailing. So we don't rule anything out, but we really do address what's next for us as where the next opportunities are that we know with our size and scope that we can do well. And so we did launch a new competitive program a couple of years ago called the STEP grants. These are relatively small grants right now, so you're probably not going to get, please fund my $10 million mission, because we're not equipped to do that just yet. But these ideas could then start that process, just like what would happen with LightSail. It wasn't the idea, it was many, many smaller ideas that led to a very large idea. That's what we're looking for. We would love to have the small thing that we can start now that then develops and develops and develops and allows us to do something extraordinary again. But we've always said that we're not in the business of solar sail. We're in the business of bringing people who love space together and doing things with that passion. So that's why we're not set on doing what's next in solar sailing necessarily. We're set on doing what's the next most exciting thing that we can all do together in space.
Bruce, another program that you coordinate, that you direct for us, the STEP grants. I'm gonna test myself here. I hope I get it right. Science and technology enabled by the public?
Yes.
It's empowered by the people.
Empowered.
I know. I was just giving him.
Empowered
I was just
by people. Empowered by people. Yeah. Damn. All right.
We considered enabled. We also considered eagle, which made no sense whatsoever. So it's quickly thrown out. Yeah, let me have one quick comment on LightSail 3, which is I kind of view it that LightSail 3 is what we've taken the big steps. We've done the demonstration. We've done what needed to be done, essentially. It's now time for those with much slightly deeper pockets like NASA to take the next steps, which are going to be much more resource intensive, and all resources, not the least of which is money, in order to fly missions at least that have a decent chance of success. And in fact, we had that with NEA Scout. We have that with ACS-3, it was Solar Cruiser. So they're thinking that way. There are groups in other countries that are trying to get private groups that are trying to take these next steps. And so we're here, and part of the legacy is to make it so whatever information we got, for whatever it's worth, here, take it, use it, do good stuff.
Here's from Violet Paola as we close in on the top of the hour. And if you two are okay with it, we can go a couple of minutes past the hour here. Thank you. How did the LightSail program contribute to our understanding of solar radiation pressure and its impact on spacecraft trajectories in the vacuum of space? And I'm thinking of like Parker Solar Probe and other things that have, like Messenger getting headed in toward the sun. They had to take this into account, didn't they, Bruce?
They did. So it's not new to take into account solar radiation pressure, the push of light, which is what we use. What's new, along with Icaros, is actually implementing a LightSail, using it as your propulsion, rather than taking it into account to adjust your orbit, or to make sure your orbit isn't being adjusted in ways that you didn't expect. So what did we learn about solar radiation pressure in the vacuum of space? Well, the catch was we weren't in a total vacuum, although it would seem that way if you got dropped there personally. And there's still atmosphere up there, and that atmosphere is why when we had a really big object with a really low mass, which is great for solar sailing, it's also a drag, quite literally. It's like trying to throw a piece of paper. It doesn't fly very well, and that drag pulled us down. So what we did learn about, or at least provide more data for other groups, is the interaction between the amount of force we got from the solar radiation pressure and the amount of drag force being used by the atmosphere, particularly once the atmosphere started to inflate as the sun started to get more active, which strangely has the effect of inflating the atmosphere, and that would drag us down faster. So both for solar sailing and also for drag sails, which is the concept of using things that have nothing to do with solar radiation pressure, but you open up a sail like ours, and indeed it increases your drag tremendously and brings your what then would be orbital debris out into the atmosphere. So how data we gathered on those things helped learn about kind of that combination but I'm not sure we didn't learn about the physics of solar radiation pressure itself. So it's more of a practical aspect.
Just a couple more here as we wrap up this live event in your community. Ethan Watkins, would a solar sail be able to come, or maybe he's thinking accelerate toward the sun, or can it only move away from it? And what I get out of that is, can a solar sail tack into the solar radiation as a sailboat can tack into the wind?
It's a good way to think about it. It's the physics is you're balancing different forces, but it's the same concept that sailboats can go counterintuitively, I would say, until you think about it very much, upwind. They can't sail directly upwind, but they can go more upwind than downwind by tacking, by orienting their sail there and the boat itself. Well, solar sails can do that by, instead of having the sail where it's pushing, the sunlight's pushing directly on it, you tilt the sail. And you tilt it based upon what you're trying to do and whether you're catching photons on the front of your motion. So that's the other thing. You're in orbit. In this case, we're talking about heliocentric orbits, orbit around the sun. And so you can turn your sail to, if the sun's here, to push you outwards in your orbit, or to push you inwards, to slow you or to speed you, which is exactly what rocket propulsion does when you do quick bursts of rockets on spacecraft, and it changes the orbit. So yes, you can go towards the sun. Right at the sun, no, but just like a sailboat, can't go right at the wind. But you can work your way inwards in the solar system or outwards by changing the orientation of your sail.
I maybe leave with a touch of the future outside of the Planetary Society, and that makes me think of the sequel to Avatar, which...
well, I mean, I think we're all thinking of that right now.
Of course. If you watch the beginning of that movie, you can see the giant spacecraft approaching that moon with a giant,
right,
I assume, laser-driven sail. But perhaps other forms of propulsion as well that it was relying on. And now if I can find the question, it's in here someplace. Here it is, from another one from Thomas West. What kinds of supplemental propulsion are light sails compatible with? What levels of thrust can they withstand before breaking up? Pretty technical, but it also leads me to asking you, Bruce, you attend those conferences about sail technology in space. What is at the forefront? What's at the bleeding edge of development of sails, building partly at least on what the Planetary Society has done?
First, as a quick comment, yes, you can drive, as you mentioned, Matt, laser-driven sails. And you use lasers or masers, something that hits the sail with light that you've got it on the Earth or in space. Again, you have to actually design that, build it, get it approved, power it, have it not break up, etc. So it's not easy, but there you can achieve faster speeds than just using sunlight, and people are definitely thinking about those kind of things. They're also working, as you mentioned with Lou, with what materials, what boom materials. They're just trying to fly the next step in missions, which NEA Scout tried to do. That ASCS-3 will test bigger booms in Earth orbit. That Solar Cruiser, and eventually someone will go out to the L1 Lagrange point between Earth and Sun and test things there. So there's, again, a lot we have to do before we get to really doing the more exotic stuff with solar sails. But that's what's out on the future and the horizon. I will mention one, I suppose weird's not the normal technical way to phrase it, but a weird new concept in solar sailing, which we have a planetary radio show that Sarah did from NIAC, from NASA. And, it's one of those new technologies. We'll see whether it develops and whether it works, but it's actually to have a transparent sail that has diffraction gratings on it, that you can adjust the diffraction and change the light actually passing through your sail and causing force. And so in theory, you can not have to turn your sail. You can change the diffraction nodules, technical term, on your sail and do so. So that's being worked on by groups as developed by, anyway, Rochester Institute of Technology and now at APL. And So that is the weirdest concept going on. A lot of discussion of metamaterials, which is exotic, thin things and things that you can do like the Japanese did with Icaros, of changing the brightness of the material or warping it in various ways by applying currents and all sorts of exotic things. So it's a whole field that's running forward that they're trying to meld with solar sail technology.
So forgive me, but it would sound like light sails have a bright future.
I've reflected on that, and I concur.
I enjoyed the chat suggestion or chat phrase of "dare shiny things."
I love that. I love that. I didn't get to see that one.
Yeah.
Shiny.
We're going to call it quits in a moment here, but we will remind you that you can learn much more about LightSail on our website, planetary.org, and we hope that you will take a look at planetary.org/legacy to learn about how you can continue to be a part of this project, which you made possible, you empowered in the first place, and help us achieve the legacy that this project deserves, including that book, which I bet a lot of you also look forward to owning someday. Jennifer, any other thoughts about this?
Yeah. Is it okay if I share my screen for a moment?
Of course.
As long as I can find out. I
am very scared.
No, I mentioned this earlier. Do you see that?
We do. Oh, that's
right.
great.
So this is the Halloween costume that just brings me so much joy. Every time I see it in our lunchroom, we have it up on our wall. And some of you may even know Heidi because she's a very active member, part of this community. Anyway, wanted to share that with you and also mention that too is part of the legacy. So part of what we're trying to do too is to get the next generation of explorers excited, motivated, excited about what's possible for public participation in space, in addition to what's possible for space exploration more generally. So I think that was a nice example of that.
Lovely. I have a 7-year-old grandson who explains to me LightSail periodically when he sees a picture of it. So thank you. Thank you both, Jennifer Vaughn, Bruce Betts, and of course, all of you out there who have joined us. There will be, if you know people who weren't able to join us for this, of course, we will be providing the recording that you'll be able to watch on demand here in the community, but it will also be in our video channel at planetary.org and in our YouTube channel as well. So hopefully many, many more people will be able to share in this legacy, as all of you do, because you have been part of making it possible. Again, planetary.org/legacy to learn about how you can help us keep building that legacy. And we will be back with many more events here in the community. Next one up, as I said, is Tuesday with one of the founders of solar sailing, light sailing, thinking about light sailing, and that is Lou Friedman, our co-founder. We will definitely be talking about sails in space when he joins us on Tuesday at 10 a.m. Pacific time. Again, the two of you, thank you. It's been great to spend this a little bit over an hour with you.
Thank you, Mat Kaplan.
Thank you. Thank you so much. And what about this community, man? I love this. I love that we get to do this all in one place, and we get to watch the chat, and we get to interact with you afterwards. So I love it so much. I'm really glad that we have these new tools. So thank you all for taking the time to talk about LightSail today and for being part of our community.
And thank you, Robin and Nicole, for helping to pull this together. Robin, who has been working behind the scenes to feed me those questions, and Amber Trujillo, who is our mistress of all of these things, not just this community, but everything else that you see in our digital channels that we use to communicate with you, all of our social media. So thank you, Amber, as well. That's it, everybody. Enjoy the rest of your weekend, and we will be seeing you again soon here in the digital member community. Take care. Bye-bye.
Thank you. Good night.